So we're here to solve the Skyscrapers puzzle by Salih. I see right at the start there's one very tiny clue, which is easy to fill in, and then a whole lot of large clues. So this is probably going to be a puzzle that uses, long runs of clues in some way. Given the starting 7 and a clue like a 6, it needs to have its largest building at least 6 cells away. This clue in the same way needs its largest building at least 6 cells away. These two 7s are pretty easy to place at the start. With a clue that's now has all of its buildings seen in each of these cells, we can put in a pretty typical Skyscrapers ladder as one set of notes, which will fulfill this clue as soon as we get to it. I can put a little bit of information in the grid about groups like the 6. So the second largest building, the 6 in this row, has to be pretty far away. The closest building has to be 1 or 2. Those are the starting points I'll put into grids in times like this. A thing that's always useful is when you recognize a space where all the buildings are seen, and this space looks like that. And it's actually where I'm going to do something I don't tend to do, but let me just do this quickly because it looks like it's going to be key in this puzzle given all the big clues. You sometimes start with these big clues with ranges of what the cells can be, and the ranges in these two cells are 1 to 4. And once we know that a 5 or 6 aren't in these cells, we still have to place a 5 or 6 in this column, but it's going to be in the context where all of the buildings are seen. And so the 6 is seen, but it's not hiding anything. So it's got to be right next to the 7. And the 5 is seen, but it's not hiding anything. So it's got to be right before the 6. And then if this is a 1, 2, 3, and if this is a 2, 3, 4, this clue ends up being satisfied. We see 5 buildings in that stretch. And so that is one way we make good progress. The 5 forces that 6 here, and at least that's one good interaction of these notes. There's not more to do yet, but these two clues look like they force the 7 in this column to be in the cell. It's got to be at least 3 away from this clue and at least 4 away from that clue, and with the 7 already to the left here, this is the only cell that remains. The 7 on these spaces, we have a lot of cells it can be, but the 7 in this row has to be in those cells. The 7 for this clue is at the top. I think one key part of these numbers is actually looking at their intersection point. So here's another clue, this 4, that has a 7 exactly 4 cells away, so all of these buildings are seen. So we're going to actually walk backwards from this building. How large can it be? It can be as large as a 4, and because it's seen, it can be as small as a 3. And so it's a case where it only has 2 options right now, which are 3 and 4. And that means the building one below it has 2 options, which are 2 and 3, and the building below it has 2 options, which are 1 and 2. And so that is, again, going to give us a case where we've got 2 big buildings to place, a 5 and 6, up top here, and not have too many choices for them. The 6 can't be right away from this 3 clue. It would hide too many buildings. You just see the 6 and 7, so the 6 is in one of these cells. And there's a tricky deduction to do with the digit 5. The main observation is the 5 can't be 2 away. If the 5 is in the cell, it moves the 6 to this cell, and then whatever building is here, you see it as well. So something 5, 6, 7, 4 seen buildings. So the 5 could be in the first cell, and then the 5, 6, 7 are seen, or the 5 could be in the third row, and then this whatever building is in this first cell, the 6 and the 7 are seen. But those are ways in these puzzles to write some notes. Well, those are tricky notes. I actually don't know that they do anything for me right now. I'm not seeing a easy deduction stemming from them. So where to look? I think the barest clue right now is probably this one, and I can do a little bit more to maybe help in this column since this column doesn't have a lot of notes. This cell has to be 1, 2, or 3, it can't be larger than that to see 6 buildings. And the same reason that this first cell couldn't be larger than 2, because 2 would be hiding 1 behind it. If this were, say, a 4 or 5 or 6, you would see a building and a 4, and then 2 and 1, 2, and 3, 2 of those digits would be hidden. And so you can, as you go one step further away, like this cell can be up to a 4, but it can't be a 5 or 6. This cell can be up to a 5, but it can't be a 6. By the time you get to here, you can finally have a cell that's as large as 6 high because you can hide a building behind it. So this is small-ish. This is small-ish. I'm wondering where the big buildings in this column can go, and I'm actually seeing 2 large 6s here that are going to take out these cells and say, can a 6 go down here? And it pretty quickly can't, again, for the same kinds of thinkings here. The range of this cell normally is 1 to 5. That it's got to be small enough that it still has seen buildings behind it, at least 2. And so if a 5 were here and a 6 were seen and a 7, you could get 4 total. So 6 can't go here, can't go in these cells, and so the 6 is all the way up top somewhere. Now what we have to do is think about the digit 5 in the same column. We now don't have too many places it can go. It can go in one of these cells. This 5 eliminates this option here. But look at this cell, which now is going to be seen by the 4. The 6 is hidden here, so we'd have a building, a 5, and then the 7. There's no 4th building to see. And so a 5 actually can't go there, but it can go in the one remaining cell. And once we place it in this cell, we're going to see this first building, see this 5, and then we need to see a 6 before the 7. That's a whole lot of involved logic, but very interesting logic to place this column. So part of the intended path of the puzzle has to be to use that clue in this way. This 6 interacts with this column to the left, which is going to place the 5 and 6 that I just did. This 6 is actually really interesting because of the clue to the right. All buildings to the right now are seen. This is the hidden building in this row, so we see a first building, second, third, fourth, fifth, and sixth building. And that means that this cell here with a 3 or 4 option has to be seen, and the only way it can be seen is if it's the largest, that's the option there. If this is a 4, and actually if this were then a 3 and a 2 and a 1, we have to make all these buildings seen, and the hidden building behind the 6 in this row looking from the right is a 5. So that's a whole lot of progress. There's actually something I didn't do here yet, but once we hide a 6 behind, the first part of this building can no longer be as large as 4. It went to 1 to 3, and with a 1 above, this range is now exactly 2, 3, so we've got a pair in this cell. And what more can we do in the grid? Well, let's just follow up on our progress. This 4 forces this to be a 5, which makes this a 1, 2, 3. These look to be a triple, which now forces this cell. And the remaining cells in that row are a 5, 6 pair. Let's look at the remaining spots for a 5. These are the other 2 cells that can have a 5. Let's look at the remaining spots for 7. These are remaining spots for a 7. So here's a 5, 7 pair and a 5, 6 pair. Let's look at the remaining spots for a 6. And besides these 2, there are these 3 cells and these 3 cells. So let's actually look at the context of a 6, and probably this cell looks the worst of all of them to think about. Like, it could have a 6, could have a 6, could have a 6. There's no clue interacting with those. These could have a 6. So it's these 3 that matter, and this is the one closest to a clue. The 4 sees this first cell. If a 6 were here, it would see the 6, and then it would see the 7. That would be very bad. So this isn't a 6. And so let's just shift to looking at this column then to see what that means. And functionally, it means a 6 is over here, and it means that a 6 must be right here. Only cell left in this column for a 6. That's now giving us a row that's got 2, 3, 4 with some options, but needs to still place a 1 somewhere. These 2 cells could be the 1, but there's a 1 right above. So that actually looks like that's going to be pretty limiting. Get a 2, 3, 4. over there. We now in this column have just a 1, 3 pair. And this cell actually looks to be a 2, 4 pair. So there's going to be some interesting things to think about in this direction. And I wouldn't typically look in this way, but just that these are pairs. One of these options is going to force all the digits near it. If I put a 3 here, it puts a 2 here, which puts a 4 here. We'd end up with 2, 3, 4, 5, 7. That's no good. So this 3 is not a possible option. The 1 is up above, the 3 is down below. This 3 pushes the 4 over here. 2, 3, 1, 2, that's still fine. We can now think about this 2, 4 pair. If this is a 2, this is a 3, we have 3, 5, 7, seeing those cells. That's not looking good. So the necessary choice there is a 4. And so this is a 2, 3, this is a 2, 3. This will be just fine. There's a 4 in one of these cells in this column. This is a 1, 2, actually 1, 1, this is a 1. Only cell left in this row for a 1. This is a 2, 7, 2, 7 pair. 2, 3, and 4. I think it's going to come down to seeing enough buildings up top. So let's think about the placement of the largest building options up here and think about how some of these clues play out. I think the clue that's most interesting is this 5, 6, 7 cycle. In one option, this will be 7 and then 6, 5, and so 7 is hiding 2 buildings. And so in that mode, you need to see 3 buildings to the left. And in the other option, it's 5, 6, 7, and all 3 of those buildings are seen, and you see 1 building to the left. And so this will be contributing 1 or 3 to the count coming from here. And with that as a constraint, it looks like there's probably something funny about the use of a 4 in this lower cell. And let me describe what I mean there. If the 4 is in this cell, the building to the left is seen, so the 1 and 4 are seen. And then the only remaining buildings that can be seen are over to the right. So this would be building 1, building 2, and then 7, 6, 5, building 3, or 5, 6, 7, building 5. But there are no sets that let us get up to a count of 4. This is an aspect of parity of these cells on the right that influence over here. And so this 4 is limited, and it's limited to not being in the cell because we'd see 2 and then 1 or 3 more. And 2 plus 1 or 2 plus 3 can't equal 4. That's a deduction I almost never see in a puzzle like this, so probably another reason for the high star rating here. So 2, 3, 2, 3, that's actually, this is a 2, 3, 2, 3 pair. We've got 1 and 4 left in the space. This has to be the 1, given the 4 is below. This 4 now means all these buildings are seen. So this is going to go pretty fast now, but we've gotten through a lot of tricky steps to get to where this is going to just flow out. But I'm looking in these columns, and after placing digits, I'm putting in the numbers that remain that are forced. In this row, we've got a 1 and 3 left to place, and right now, 2 eliminates this clue down to be a 1. So this is the 1 and 3. Both of these cells are seen, so 1 is below 2. In this case, both of these cells are seen, but they're also the 2 options left in the column, 2 and 3. There's a 3 in the cell. There's a 2 here. 3, 2, 3. Last digit 4. And we've gone through this whole grid. It's got a real range of less common skyscraper steps, but some of that really stems from the layout of the puzzle. Aside from this very small clue at the start, I was really using large clues to place 7s and place sets of clues. I think the way I'm remembering it, we had 6 cells seen here, 5 cells seen here, 4 cells seen here. Basically, as some of the 7s went into the grid, we had strictly increasing series that forced a lot of constraints in the grid. one of the nice interactions was these two starting clues limiting the 6 and 5 down here. But the hardest thing to really catch was, I think, this column. And it was recognizing that while there's not a lot that interacts with it, the big digits are pretty hard to place right near these clues, right off this edge. And that gave us a limitation of the 6, 7 that got us up to the start and got us over to the rest of the puzzle. So if you got through any part of these steps like I just did, you're probably a Skyscrapers master. If you didn't get through some of these steps, hopefully you learned a little bit from this video. We'll see you again soon.